In this video, you'll see how to analyze your application's performance with AWS X-Ray Analytics. Using the X-Ray Analytics console, you can visualize traces collected by the AWS X-Ray service, analyze trace data for your application and its underlying services, and identify issues. The AWS X-Ray Analytics console generates two primary graphs to help you visualize traces: response time distribution and time series activity. You can filter the trace data shown in multiple ways, such as by selecting a time range. You can filter data by groups you have defined. In this case, we'll use the default group. You can also filter data using custom filter expressions. The help screen provides guidance for this. In this case, let's view traces with response times greater than 1 second. You can also use the service map to filter traces for a specific service. Select a service and then choose what information you want to see. In this case, choose Analyze Traces. Now, X-Ray Analytics shows only traces that contain the selected service. Next, let's look at two ways you can compare trace data sets in X-Ray Analytics. First, let's compare sets of traces before and after the launch of a new version of the application. To get started, create a filtered trace set by selecting trace data generated before the launch. Next, click Compare to create a second trace set with data generated after the launch. This color-coded view allows you to easily compare performance over the two time periods. As you can see in this response time distribution visualization, the latency is similar before and after deployment, which indicates the deployment had little or no effect on latency. Now let's clear the filtered traces and compare the data a different way. This time, let's compare trace data with response times above and below the 95th percentile. Here you can see that the tail latency, that is, latency above the 95th percentile, is fairly distributed across the time series activity visualization. If the time series visualization showed a small number of highly concentrated green squares, that would indicate the tail latency could be isolated to a specific time range. Scroll down the page to view additional information about the trace sets. These tables show data grouped by various dimensions, such as HTTP status codes, HTTP methods, URLs visited, and more. The delta column in each table calculates the difference between the two trace sets. A larger delta indicates a more significant difference. For example, the top two rows in the URL table have large deltas, which could mean there's a latency issue for those two images. You can also customize the tables. For example, you can view data by user ID, which is an example of an X-ray annotation, or add information that you recorded about your traces in your application. Scroll down to see the response time root cause and trace list tables. AWS X-Ray Analytics indicates that the image service is contributing to more than 60% of the delta in response times between the trace sets. Let's select the image service to filter the tables to show data for just this item. You can investigate further by selecting a specific trace to view more details. This screen includes a trace map for all services that were part of this trace, as well as performance details for each segment. You can select a service on the map to highlight its data below. Notice that the image service is contributing to the long response time for this trace. You can take findings from initial investigations such as these to your development team, so they can further analyze the cause of application performance. You've just seen how to analyze your application's performance with AWS X-Ray Analytics. Thanks for watching. Now it's your turn to try.